Okay, chapter 3-2, logarithms. Logarithms are inverses of exponential functions. An exponential function looks like f of x is equal to a to the x. If you're an inverse, there are some properties that you should understand about inverses. One property you should remember is that if you are inverse functions, then you have to be a one-to-one function, right? If you are inverses, then what do we know about the domain and range? Domain and range swaps out. So your x's become your y's, and your y's become your x's. Okay? What else should you know about inverses? They're reflected over what light? What kind of a line? Line of y equals x. Okay? Now, if we talk about all this, it's reflected in the line y equals x. The x and y values flip-flop, and in order to have an inverse, you must be a one-to-one function, meaning you must pass the horizontal line test. To be a one-to-one function, are you allowed to choose both ice cream and candy?
No.
No. Can anybody choose Jenna's favorite ice cream of Moose Track? Is anybody allowed to choose her ice cream? No. Moose Track is hers and only hers. It's her big cup. Nobody's allowed to get it. Okay, we all understand that. Once she's chosen, it's hers and nobody else can have it. Now, let's graph. F of x equals 2 to the x. I just want to make it very clear that on your next slide is graph paper because third period did not see the graph paper. So, we're first going to complete an XY table. Okay? So before you start graphing this, we're going to make an XY table on that slide. So if I want to make an XY table here, I have 2 to the x inside here, and we are simply going to plug and chug the values -2, -1, 0, 1, and 2. This is something we've been doing for how long now? You guys should have this function memorized. Okay? 2 to the -2 gives you 1 over 2 squared, which gives you 1/4. 2 to the -1 gives you 1 over 2, which gives you 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. Now, I just told you that exponential functions. No, feel free to take the ones. Okay. Right, now, I just told you that exponentials and logarithms are what? Inverses of one another. Now, you don't know this yet, but I'm going to tell you. Log base 2 of x. This is what we're going to graph. I just told you that if they're inverses, what do we know about their x and y values? They swap, right? So instead of having -2 1/4, we're going to have 1/4 -2. Correct? What's the next ordered pair we should have?
1/2 -1.
1/2 -1. What's the next one?
1 0.
1 0.
2
2 1.
4.
4 2. These are going to be your inverse ordered pairs. Do we understand that? Now, with that said, now what we're going to do is actually we're going to come over here. We're going to graph those points. The first thing we're going to graph is the exponential function. The exponential function was 0 1. Yes? 1 2. 2 4. -1 1/2. -2 1/4. Now, we know what an exponential function looks like. It's that little curve, okay? It gets really, really close to what axis? The x-axis, but does it ever cross the x-axis? No, it does not. So my question to you is can you tell me the red graph up here, which is going to be your exponential function, can you tell me what the domain of that function is, and how do we read domain graphically? From left to right. So tell me, what is the domain of this exponential function?
Negative.
X is an nominal real. There is no restriction on here. From -infinity to infinity, that is correct. There are no restrictions on this domain, because for every x value, there is a corresponding y value. Do we agree with that?
So we have some more restriction.
I'm sorry?
They can show us one more restriction.
We're not there yet. Okay. Now, the intercept. The intercept is going to be what? 0 1. Well, what type of an intercept is 0 1? This is a y-intercept. Okay? Then, the asymptote. y equals 0. Y equals 0 is what type of an asymptote? It's a horizontal asymptote. We understand that. Okay? Well, now let's go and graph the other function. The other function was our logarithmic function. So instead of having the point 0, 1, we're now going to have the point 1, 0. Instead of having the point 2, 1, what am I going to have? I'm sorry? Instead of the point 1, 2, I'm going to have the point 2, 1. Okay? Instead of having the point 2, 4, I'm going to have the point what? 4, 2. Instead of having the point -1 half, I'm going to have what? I'm going to have half -1. Instead of having -2 1/4, I'm going to have 1/4 -2. And again, we're going to connect these. Now, these are supposed to be reflections over what line? Y equals x. So here's my line y equals x. Do we all see that? Are they reflections over the line y equals x? They absolutely are. Are they one-to-one functions? Yes, they absolutely are. Now my question to you is, what's the domain of my logarithmic function? 0 to infinity. Can it be 0? Can it be 0? Is it ever going to touch the y-axis? No. So what does that tell you? It's never going to cross it. There's not a y-intercept, which means what about my intercept? It's an x-intercept, and my x-intercept is the point 1, 0. And this is my x-intercept. What does that tell me about my asymptote? I have a vertical asymptote at x equals 0 instead of a horizontal asymptote at y equals 0. Why is this like this? Because they're inverses, correct? Because we read domain from left to right. As x is really small, do I have a corresponding y value to it? I do. It's just so close to 0, I can't distinguish between that and 0. As it gets really big, do I have a corresponding y value? Yes, they're up in the sky. So my question to you is on the logarithmic function, do I have any x values, y values corresponding to the x values at -10? No, there's nothing down here. Because it doesn't start until it's at 0, or close to 0. Okay? All right. Now, the definition of a logarithmic function. For x is greater than 0 and a is greater than 0 and a cannot be 1. Y is equal to log base a of x if and only if x is equal to a to y. This means nothing to you until we do examples. This means absolutely nothing to you until we do examples. Okay? If and only if, yep. Okay. Log base 3 of x is equal to f of x where x is equal to 1. Is there an example on the bottom of that page? Yeah. Huh. I must have deleted it. What is it? Log 3x and x equals 32. F of x is equal to log base 2 of x where x is equal to 32. Now, all this means is we're going to put in place of x what x is. What is x? And in place of f of x, what is f of x also known as? 1. Now, our brains work differently in this classroom. One person may think one way, another person may think another way. So I'm going to present this in both manners, okay? What we need to do is we need to write this as an exponential function, because our brains do not think in logarithms. So what we need to do is we need to find the base of that logarithm. What is the base of that logarithm? The base is 2. Now, if we write an exponential also is going to have a base, but instead of it being small, it's going to be large. Okay? Now, the exponent on my exponential is going to be actually what is equal on the log across the equal sign. So what is across the equal sign? Y, so we're going to have 2 to the y. And that is going to equal the large number beside the small base of the log. What's the large number there? 32. Now from here, our brains kind of do a little sideways walk. It just depends upon how you think. Some people may say, well, I want to break down 32 to have the same base as 2. So 2 raised to what power is 32? So 2 times 2 is 4 times 2 is times 2 is times 2 is. So what you're telling me is 32 is 2 to the 5th. And what do you notice about your two bases? They're the same. So if my bases are the same, what can you apply about your exponents? The exponents have to be equal. Do we understand that? If your bases are the same, then your exponents have to be equal. Now somebody else may say, no, I don't think like that, Mr. Garrett. I want to say to myself, well, 2 raised to what power gives me 32? You simply want to do the math in your head. And you don't want to mess around making equivalent statements, and you're just going to simply say, well, 2 to the 5th is equal to 32, and that means it's 5. I don't care how your brain works, just as long as you get it done. Do we understand that? Now, here we go on this one, exactly the same example, so I need you to do what here?
Oh, last one, so 6, where x equals 50.
What?
Say like x equals 50.
Let's first do these examples, and then we'll see if it clears up your question. Okay? Because I don't want you confusing everybody else with different numbers in there whenever they're not seeing what you're saying. Okay? So, here we go. Log base 3 of x is equal to f of x, where x is equal to 1. What do I do? I'm going to put 1 in for x. What does f of x turn into? Y. How do I write this as an exponential? Your base is 3. Where does my exponent come from? Across the equal sign, and that has to equal 1. Now you tell me, 3 raised to what power is 1? 0. So, y is equal to 0. Okay? Do it again. Before we do that, I want you to understand something. We have what we call a natural log. A natural log is the same thing as a log with a base of e. If you see log base e of x, which you never will, you're never going to see that. You're never going to see log base e. What they will write is ln of x. Many of you are sitting here saying, well, ln of x does not make sense because why is it ln when it should be nl, meaning natural log? I have no idea. That's just what they did. Okay? So, we have some properties of logarithms that you need to know about. Properties are log base a of 1 is equal to 0. Notice every time I give you a logarithm, what else am I giving you? I'm giving you an exponential, because what does your brain understand? An exponential, meaning anything raised to 0 power is always in power 1, right? That makes sense. I'm giving you a log and saying log base a of a is equal to 1. Why is that true? Because a to the first is equal to a. What I want you to understand here is whenever I have log base a of a, it's just like 5 divided by 5. Those cancel out. Does that make sense? Look at the next one. Log base a of a is equal to x. Well, what do I want your brain to think about? 5 divided by 5 is 1. So this is gone and you're left with x equals x. A to the log base a. That's gone and I'm left with x equals x. Do we understand that? Okay. Over here, if I have log base a of x equals log base a of y, then what would that imply? The log base a's cancel out and I would have just x is equal to y. Do you understand that?
I was afraid that base, wait, so the whole number base and the base and the exponent cancel out the whole entire thing.
Yep. Because if you write this as an exponential, a to the x is equal to a to the x. Which is why you can cancel it out and just say a is x is x. Okay? Now, all the natural log bases apply here also. Okay? Same properties, just instead of having log base a, put log base e, which is the natural log. Now let's do some examples of this. Log base 2 of x is equal to log base 2 of 5. What can you do? Log base 2 goes away, and what do you got? That's simple. What What do you notice about log base 4 of 4 is equal to x? What cancels? That cancels. What am I left with? 1 is equal to x. Nope. The next one, log base 5 of 5 of x is equal to, that's supposed to be an equal sign, right? Is equal to 25, so what's that give you? So log base 5 of 5 cancels out, and I have x is equal to 25. Log base 5 of 5 to the x? No equal sign, is there? There's no equal sign there, is there? This is gone, and it is just simplification being x. Just simplifying, so it's just x. E, 7, log base 7 of 14, what happens? Those cancel out, and you're left with just 14. Now, same exact properties, I printed those out for you so that you can see them in logarithm properties. And then I also have the worksheet, and we're going to start with the worksheet. I'm going to give everybody the worksheet here. How do you do that? Okay, number 1, it says rewrite each equation in exponential form. Rewrite each equation in exponential form. I can do log base 6 of 36 is equal to 2. How do I write this as an exponent? My base is 6. I look across the equal sign for my exponent, that gives me 2, and it equals my big number, 36.
That's all you do for one.
Yep, that's all you do for problems 1 through 4. If I have time, I'll come back and do more problems. I'm trying to get one for every section, okay? Number 5, rewrite each equation into logarithmic form. So 64 to the 1/2 is equal to 8. What's my base? So what's that going to be? Log of 64 of 8 equals 1/2. Good job. Yep. Number 9. Rewrite each equation in exponential form. We're going right back to problems 1 through 4, right? So what's my base? Due to the equals. Good job. 15. Rewrite each equation in logarithmic form. So we're going right back to writing it as a logarithm. What's that base going to be? Log of u, log base u of v equals negative 14. Good. Turn it over to 21. Evaluate each expression. This is using the property. So how do I evaluate this? Okay. Can I express 64 differently? What's my base? 4. I would like to express 64 to have a base of what? 4 raised to a power. So 4 times 4 is? Times 4 is? So what you're telling me is that 64 is 4 cubed. Would we agree with that? Yes or no? Now what can you do with the log base 4 and 4? Those cancel out, you're just left with 3. Log base 4, 16. What am I trying to express this with? A base of what? What's the base currently? 4, so what do I need to change? 16. So that's going to be log base 4 of 4 squared. That's going to be a 2. Okay, so let's do the next set of instructions, and we'll go back to B2. 31, 12, log base 12 of 144. What happens? The 12s cancel out, and I'm left with 144. Okay, Do we feel like we have an idea what's going on with this worksheet?
About 34.
34? 34. 9 log base 3 of 20. Well, can I express 9 differently? That's going to be 3 squared times log base 3 of 20, right? So what's that going to give you? 2 log.
40.
Which gives you 40. Okay, do we have a clue what we're doing? Have a great one.
I taking a quiz tomorrow.
Yes.